Good morning, students. In the previous sessions on the chapter sets, you have learnt about the definition of a set, which is a well-defined collection of objects, and the notation, how to denote a set and how to represent a set. There are two ways of representing. One is the set builder form, the other is the roster form. Roster form is we write the actual elements of that one. Set builder form is we just mention the rule that has to be satisfied by all the elements of the set, and we have worked out some problems in which we have converted one way of representation of the set to other one. That is, if it is expressed in the roster form, we have written the set builder form. So if it is in the set builder form, we have written in the roster form. So we had worked out problems and we have learnt about the definition in the earlier session. In today's session, I am going to teach you the types of sets. Types of sets. Now, one by one, that is how many types of sets we will be considering, we will be discussing in this particular chapter. Now, the first one is known as an empty set. It is an empty set. See, the word itself, the word empty itself tells that there is nothing in the set. It's a very clear, the word that we are using here, it gives us the clear definition itself. That is, a set containing no element, or if a set does not contain any element, then it is called an empty set, or we call it as a null set, or it is also known as a void set. Empty set or null set or a void set. All the words are used here. So, a set which does not contain any element is called an empty set or a null set or a void set. Next is how to denote it. See, we use this one, this notation. It's a Greek alphabet phi, we read it as phi, the spelling being PHI, or you can write the empty brackets like this. Don't write 0 there. Nothing means don't write 0. If you write 0, that becomes an element here. So you have to be careful here. So a set which does not contain any element is called a null set or a void set or an empty set. And how it is denoted is by the Greek alphabet phi, or empty brackets we write. Empty, a pair of empty square brackets, empty flap brackets, that gives you the notation for an empty set. Now, we can think how a null set can exist. Certainly, by putting a particular condition, we can say that no element belongs to that one. Now, let me take an example. Let the set A be defined like this. Let the set A contain all x such that x square minus 3 equal to 0 and x is rational. X is a rational number. Suppose a set is defined like this. If the set A contains all x such that x square minus 3 equal to 0 and x is a rational number. Now what is this one? It is nothing but a quadratic equation. Let me solve the equation. X square minus 3 equal to 0 implies x square equal to 3, that is x is equal to plus or minus square root of 3. Now plus root 3 or minus root 3. What type of a number it is? It is an irrational number. Whereas I have written x is rational. That means that these elements do not satisfy the condition. That means these elements cannot belong to this one. So in this case now, according to the condition that has been specified, I can write that A does not contain any element. Therefore I can write A is equal to 5. It does not contain any element. So, by defining a set in a particular way, there may be some element, there may not be some element. So, if the no element is present in that one, then we can say it becomes an empty set. Similarly, let me take another example. Let the set B be defined like this. B containing all x such that x square equal to 9 and x is even. Suppose a set is given like this. We are asked to find the elements of this set, and according to the condition x square equal to 9, you can clearly see that it is again a quadratic equation. X would be equal to plus or minus root of 3. But what's the second part of the condition? X should be an even number. Whereas what is 3? It is an odd number. Plus 3 or minus 3, it is an odd number. So in this case also, that becomes a null set. This is how we just consider. Or generally, if you consider a first PUC class itself, suppose usually the age group of first year PUC students, it would be between 15 and 17, let us assume. Suppose I tell you, consider the set of all students of first year PUC who are above the age of 25 years. No student belong to that one, isn't it? Therefore, I can say it becomes a null set. So depending upon the rule, the condition that has been specified in the set, we can say that the element may belong or may not belong. So if no element is there in a set, we call it as an empty set or a null set or a void set, and this is the notation. Now let us come to the second set. It is finite set. See, the word that we are using that directly gives you the definition. What do you mean by finite? Finite means we know the exact elements here. So if a set contains a finite number of elements, now we call it as a finite set. For example, the alphabets of a language. We are sure Kannada it may be 50, Kannada it would be 52, English 26, like that. Different languages have different number of alphabets. So depending upon the language that we are considering, we can say it is a finite set. That's an example. So if a set contains finite number of elements, finite means countable, we will be knowing the exact number of elements, then we call it as a finite set. I told you already the alphabets of a language or the students of a class. In a class now, certain number of students would be there. Whatever may be the number, it may be a very huge number also. Still we consider it as a finite set because we will be knowing the exact number of elements. And then population of a country. See, by taking the census now, we will be knowing how many people are residing in a particular country. And suppose you take an example here, the set A containing the numbers 1, 2, 3, 4, 5, 6. If you just put dashes, no, then we will not be knowing the exact number. You know, 1, 2, 3, 4, 5, 6. How many elements are there? There are 6 elements. So we know exactly there are 6 elements in the set A. Similarly, take another set B. It is 3, 6, 9. How many elements are there? There are only 3 elements here. So these now they are called as the finite sets because it has exactly 6 elements, it has exactly 3 elements. So in the case of a finite set, the number of elements present in a finite set is called as its cardinal number. We use another word for that one. The number of elements in a finite set is called its cardinal number, and we usually write it like this. Here n of A. N, we use a small letter n here, n of A, that tells us how many elements are there. How many? 1, 2, 3, 4, 5, 6. So I can write it as n of A is equal to 6. Similarly, you take the second set, 3, 6, 9. How many elements are there? There are only 3 elements. So how do you write that one? N of B is equal to 3. So depending upon how many elements are present, if you write n of that set, if you denote like this, you have to write the exact number of elements that are present in that one. So this is called as the cardinal number of the finite set. So finite set, only we can think about the cardinal number only in the case of a finite set. So in the case of an empty set, now the cardinal number would become nothing, 0. And in the case of finite set, now we will be knowing the exact number of elements here. The third one is, after finite, what can be the next one? It is infinite. It is an infinite set. What I mean by infinite? If you do not know the exact number of elements, that is, if the set contains infinite number of elements, we call it as an infinite set. In the very first session, I had given you some standard sets. What are they? Set of the natural numbers and set I or Z. We use it to denote the set of the integers. Next, Q, the set of rational numbers, or the set of real numbers. So all of them, now you can see that all of them, they are called as infinite sets. That is, how do you write n here? It is 1, 2, 3, 4, we put dashes like this. That means that we do not know the exact number of elements. All of them are called as infinite set because we cannot, suppose I give a number 1000. There is one more than that one. If you take that number, there is one more than that. Therefore, we cannot write the last element of this one, or will not be knowing how many elements are present exactly in the particular set. So, all of them, the set of these number sets, I mean natural number, integer, rational number, real number, all of them, no, we take them as infinite set because we do not know the exact number of elements, or we say the set which contains infinite number of elements is called an infinite set. The next one is called as singleton. It is called singleton. Singleton means a set containing only one element, that is called a singleton. That means it should have only one element. Whatever may be the element, we are not considering, I am not telling a particular element here. So, a set which contains only one element is called a singleton. Suppose I denote a set like this. Let the set A contain all x such that x is a prime number. X is a prime number and x is even. X is even. I have given the definition of prime number in the earlier classes, even you are familiar. A prime number is the one which is greater than 1, which can be divided by 1 and itself, is called a prime number. What is the first prime number? 2. Then 3, 5, 7, 11, like that, isn't it? And you observe all the remaining prime numbers are odd numbers, starting with the 3. 2 is the only one even prime number. So, a set A contains all x such that it should be a prime number and it should be an even number. So, how many elements are present? Only one element is present. So, we can take this as a singleton. So, singleton means it should contain only one element, that is called a singleton. Depending upon the definition of the particular set, or depending upon the rule that has been specified, we just consider it as a singleton. So, a set containing only one element is called a singleton. The next one is equal sets. Equal sets. What do you mean by the equal sets? See, suppose there are two here, we consider two sets here. Say set A and B. Suppose there are two sets here, A and B. Now, if both of them contain the same elements, not the same number of elements, they should contain the same elements, we call them as equal sets. So, two sets, say A and B, are said to be equal if they contain the same elements. For example, let A contain the elements 1, 3, 5. Let B contain the element 3, 1, 5. Look here, the elements are present here. Same elements are present. Of course, I have told you in the representing a set, the order is not important. We don't write according to increasing or decreasing order because it is only a collection. In whatever position you want to write, you can write, but they have to be separated by comma. That's the only condition here. A contains the elements 1, 3 and 5. B contains the elements 3, 1 and 5. Now, that means I can say the sets A and B are equal to each other, and the usual notation of equality we write. So, A is equal to B. So, we say if two sets having the same elements, no, they are said to be equal to each other. Suppose this set B has an element, one element extra, 3, 1, 5, 6. You see that there are 3 here, there are 4 here, but these sets are not equal. So, what we do? We say A and B, they are not equal to each other, or they are unequal. That is, they are containing different elements here. Therefore, we say the sets are equal or sets are unequal. So, here we have discussed about 5 types of sets here. First one, an empty set. So, if a set does not contain any element, we call it as an empty set. So, depending upon how the set is defined, there may be element, may not be element. If the set doesn't contain any element according to the way it has been defined, then we call it as an empty set or a null set or a void set, and we denote it by empty brackets, or we use the Greek alphabet phi. The first one. Second one, if the set contains finite number of elements, then we call it as a finite set. That means we should know the exact number of elements present in the particular set. Then we call it as a finite set. Third one, infinite. Infinite means if the exact number of elements are not known to us, if there are infinite number of elements are present in the set, we call it as an infinite set. The next one, if a set contains only one element, we call it as a singleton. Finally, if two sets are there, say take set A and B, then the sets A and B are said to be equal to each other. We use the same notation, A is equal to B, if they contain the same elements. Suppose there is change of even one element, now we say they are unequal sets. So these are the 5 types of sets we will be considering. Now, usually the definition on the set types of sets will not be asked. The problem on the types of sets would be expected. We will take up the problems in the next session. Thank you.